So today's objective, oops, it's funny how this always remembers the last color I used, is to understand and solve an equation for a specified variable. Specified variable. Is that a, does this look right? Should it be a Y? I think it's an I. Now we're going to get this from our online book, and this is lesson 4.3. Okay, so you can read that lesson along with what we're doing. So first off, we're going to talk about the two cases in which we're going to work on this. Okay, so case one, and this is the most common application, is for a formula. So let's make sure we all understand what is a formula. So a formula is an equation that describes a relationship among quantities. And yesterday we talked about a couple of formulas. We talked about perimeter of a square. We talked about perimeter of a rectangle. We talked about area of a square, area of a triangle, area of a rectangle. And there was only mainly variables. So, for example, in the area of a rectangle is just A equals LW. Area equals length times width. Okay? And for many years, you've used formulas exactly in the form they were given to you. Somebody gives you the length, somebody gives you the width, you multiply them, and you figure out the area. But as we get further into math, now what happens is somebody gives you the area and somebody gives you the width, and your job is to figure out the length. And so what we're doing in these problems is we're actually not going to give you any numbers. We're just going to say, what would this formula look like if it just had the length by itself, okay? And so it's an equation, so all the rules that we've used for equations still are going to hold true, regardless if it's numbers or variables. We're still going to do inverse operations. We'd still do distributing if there was parentheses. We would still combine like terms if we could, and so on and so forth, okay? So let's do a little practice on this one, and then we'll move on. So basically what we're going to end up doing is to follow this direction. Solve the formula for the indicated variable. Okay, and you're going to see a problem that looks something like this. Let's see. The formula B equals L times W times H is used to find the volume of a rectangular prism. L represents length, W represents width, and H represents height. Okay, so that's where that formula comes in, and you guys should be familiar with that formula, and we may be using it off and on through the year. Geometry class, you have no hope. You have to use this one. So they're going to then indicate, we want, instead of V alone, we want you to solve the formula for H. Okay. So what you're going to do is you could take that equation if you wanted to, and we want to solve for H. That means we want H on the left, correct? So what we could do is rewrite this equation, LWH equals V, and the reason why we could do that would be the symmetric property of equality. Symmetric says you can take an equation and switch what was on the right to the left, what was on the left to the right. Okay, now, what math is happening to the H? Multiplication. So the inverse of multiplication is division. So what we're going to do is divide both sides by the LW. So this is division property of equality. Oops, forgot my prop. When I do division property of equality, I get H equals V over LW. And that is where the problem ends. That's it. That's as simple as that. Okay? Now, you may see a little bit more complicated formulas. Let's do one that has a little bit more stuff to it. Let's have the formula E equals 1/2 kx squared. Now this formula finds the potential energy E of a spring with spring constant K that has been stretched to a length x. So to solve this formula, I don't need to know anything about the formula, but just to let you know, this is one that we use in physics. Okay, and you may actually end up using it this year. I don't know if it shows up in your physics class or not. The question says, I want you to solve this for K. So again, the K that I want is on the wrong side. So I'm going to go ahead and use that symmetric property again and rewrite the equation as 1/2 kx squared equals E. So that is, again, the symmetric property. Of equality. All right. What do you think would be the next best move? Because, again, what I'm trying to get rid of, or get by itself, is K. And I've got two things that are bothering it right now. Okay? So, Maddie, what do you think? Yeah, those are the two that I need to get rid of. So how am I going to do that? And I'm going to recommend that we take 2 steps in this. Okay? Just because the two things we need to get rid of are very different. Okay, Lucas?
To get rid of the half, you can multiply it by 2.
So what we can use is our strategy that if we have a coefficient that's a fraction, we can multiply both sides by its reciprocal. So we get kx squared equals 2e. So that, again, that was the multiplication property of equality. Okay, now what? Now what are we going to do? Maggie?
Divide by x squared.
Yeah, we need to get rid of that x squared, so we're going to divide since that's the opposite or inverse of multiplying. So we end up getting k equals 2e over x squared. And again, that was the result of the division property of equality. And that's what they're asking us to do. We're not going to be able to figure out what k equals because we don't have any information about e and x squared. So we are done. Okay, you guys get the handle of that? Okay. So that's all that you guys are going to be asked to do. Yes?
So if it was like 1/3 kx squared, would you multiply it by 3?
Yeah, whatever the reciprocal of that coefficient is, that's what I would be multiplying by. Okay? All right, so then I said, remember, we've got 2 different types of equations. We've got formulas and then this new term that they talk about in the book. Ethan?
For symmetric property, could it be commutative or?
No. Commutative is in an expression.
Oh, alright.
Okay? Symmetric has to be in an equation. Big difference between the two. Very similar what it looks like, but one is over an adding sign or a multiplication sign. The other one is over an equal sign. Okay? All right, so the other vocab word to share with you is this one called a literal equation. Now, I've never heard that term itself, so I want to make sure that you understand it because I believe it shows up on the homework. So I want to make sure that you have a fighting chance of being able to do this, understanding what the word means. So they say a literal equation, and this is kind of funny, is simply an equation with two or more variables. Okay, so all formulas fall under that category. Well, yeah, all formulas fall under that category of literal equations. Okay, but what they're saying is any equation that has two or more variables is a literal equation. Certain literal equations are actually formulas. Okay, so there is a slight distinction between the two. So again, we're going to solve a literal equation exactly the same way that we would solve a regular equation, except for we're going to get a variable on one side and a lot of variables on the other side too.
Are the equations that we just solved literal?
Yes, and that's what I just said, is that all formulas are literal, but there are some literal equations that aren't formulas. And that's what we're going to look at right now. Okay, so let me give you a couple doozies. And again, directions on these are going to say something along the lines of solve each literal equation. For the indicated variable. Okay. So let's see. We're at example 3, is that right?
Yeah.
So this is what you might see. A times the quantity x plus b equals c, where a can't equal 0, and then it's going to ask you, and then it's going to say for x. So I'm copying literally directions you might see on homework. So they're making a stipulation. Why do you think they're going to tell you that a can't equal 0? Where do you think a may end up in your answer? So that it has no ability to equal 0. Patrick?
Then C would equal 0?
Okay, nope. All right. Ian, you got an idea?
Because if a was 0 and you distributed it to x plus b, it would equal 0, and c can't equal 0.
That's not the real reason. Let's solve it out, and I'll ask the question again. Okay. Now, notice that it didn't say, like the last one. It sounded a little nicer when they were doing the formulas. They said, solve the formula for the indicated variable, and they would end the question with solve the formula for h, solve the formula for k. This one says, here's your equation, gives you a restriction, a can't equal 0, and then it says for x. So what that is telling you is you need to solve this equation for x, okay? So what would be our first step in this problem? There's actually 2 ways, and I'll show you if you, whatever way one person tells me, I'll show the other way as well. Amanda. Okay. So we can start with distribution. And we get a times x is ax. And then a times b is going to give us ab, so positive ab equals c. So that was the distributive property of equality. All right, now what? Remember, our job is to get x alone, so what would be our next step? Chris?
Subtract A and B.
Yeah, we have to subtract that little partnership here, AB, from both sides. And that would give us AX equals C minus AB. And that was the result of doing the subtraction property of equality. And then we need to, still haven't gotten x completely alone, so we have one more step to do. So Brian?
Divide A on each side.
So we're going to divide both sides by a. And we get x equals c minus ab over a. And again, that was the division property of equality. Now, can somebody answer my question? Why did they have to tell us that A couldn't be equal to 0? Looking at the result we got. Spencer?
There'd be no solution
Okay, why not?
because 0 doesn't go into C minus A or B.
Say again?
0 doesn't go into C minus AB.
Okay, that's not the reason why. Amanda?
Because 0 can't be a denominator?
Right. What are you, when you put 0 in the denominator, what math are you actually trying to do in the problem? You're trying to divide by 0, and that's the one thing in math we can't do. So that's why they had to put that stipulation that you can't divide by 0, so that A could be any value but 0. Okay? Now, let me show you an alternative to this problem. What if we did this? Divide both sides by A. We get x plus b equals c over a. Subtract both sides by b. And we would get x equals c over a minus b. Now, if I wanted to have one fraction in my answer, I could multiply b by a over a. And I would get x equals c minus ab all over a. So that's an alternative to solving when you have, instead of distributing, you could divide both sides by that variable. Okay, so that's a thought to have. Now, would you see an answer listed as the next to the last one, the x equals c over a minus b? And the answer is sometimes, yeah, you might. So be careful with that. Because if you notice here, let's look at this guy for just a sec. We have x equals c minus ab over a. I can create two little mini fractions and simplify. And then I have that original answer I got the second time I did the problem. Okay? All right. You want to do one more? You feel good about this? Oh, mixed review. All right, let's try one more. Uno más. Bueno. Okay, so we've got A equals 1/2 H times the quantity B1 plus B2. Anybody recognize that's actually a formula? What is area of a trapezoid? It's area of a trapezoid. Okay. All right. So this one's again, we're going to get a stipulation where H cannot equal 0, and then it says for B sub 1. Okay. So first thing I notice is that the B sub 1 I'm supposed to solve for is on the right side. So me, out of my habit, I'm going to use that symmetric property and rewrite 1/2 times, oops, sorry, forgot the H. 1/2 H times the quantity B1, B sub 1 plus B sub 2 equals A. So that is our symmetric property. Love that property. All right, so how would I begin this one? Because I got so much math going on the left side to get B sub 1 by itself. What would be the first thing I would attempt to do? And I'm going to say distributing would be a pain in the behind on this one. Big behind. Tristan B.
You get rid of the fraction.
Okay, and how would I get rid of the fraction?
Times 2 on both sides.
We're going to multiply both sides by the reciprocal. And we get H times the quantity B sub 1 plus B sub 2 equals 2A. So that was multiplication property. Here's another way of writing the property out of equality. All right, think about what I just demonstrated. What would be the best next step, Johnny? Mr. Johnny Ray.
Distribute the H
Not so much. Not so much. Remember, we're trying to use something we just talked about. Tristan M.
Divide by h.
Yeah, let's not distribute. Let's get rid of that h by dividing both sides by h. This might make this a lot easier. So I get b sub 1 plus b sub 2 equals 2a over h. So that was division property of equality. So here's a different way of saying that. And then, what would I do? Chris?
Subtract b2.
I'm going to subtract b sub 2 from both sides. Notice that I keep saying sub so that you don't confuse it with an exponent. And that's how we actually do read that number. So I get b sub 1 equals 2a over h minus b sub 2. So that was our subtraction property of equality. That allowed me to do that. Now that answer is perfectly fine. I don't need to have a common denominator. I could, if I had a common denominator, what would you write the answer as? Amanda?
Minus h sub 2 over h.
And that's what the answer would look like if you wanted a common denominator. Okay? All right, Brian.
Could you also subtract b's 1 on the other side?
Remember what you're trying to solve for. So you don't want to do math with him. You want him to stay put. You want math to be done to everything else around him. Okay? Because you could do that, but then you're going to add extra steps. Okay? All right, that's that.